Okay, I want to quickly talk about how I'm imagining you're going to use the data collection tools to get the velocities for this puck as it falls down the ramp. So I've already finished the getting started and the graphing and data collection tips. I'm on this section about collect your data and make a graph. We've got the tool that allows you to play videos to see the puck running down and the way that it levitates as it goes. And you can move it one frame at a time like that. And you can set up these tools to measure exactly how high it is when it started. So we'll set a marker to show where it is when it started and a second one when it gets down to flat. I can see that it's not quite flat right there. There we go. I'm going to put that at the center of the puck and then back this up to when it was up at the top of the thing and put that at the center of the puck. Because the height that I want is how much the height changes from the beginning to the end. And so I need a measuring tool to be able to see that. And I also want a horizontal line so I can show like, this is where it ends up in height. And that's where it started from. So I'll line that up at 0. And then I can use this to measure the exact height that it started from. It looks like that one is 25, 26, 26 and a half centimeters. So for that very first one down in this data table, I would say 26.5 centimeters in height. And then I want to move this down to when it's down on the flat part. And then I'm going to try and measure the speed once it's down on the flat part. So to do that, I need to know how far it travels for a couple of frames, because during this flat part, it's presumably not changing its speed anymore because it's not speeding up as it falls and it's not experiencing friction yet. So I want a horizontal ruler so I can measure how far it travels. Oops, move that thing. I'm going to move this. And then I want the stopwatch so I can see a time frame and say this is the 0 point. So I'll reset this time so it starts at 0. And it starts at 0 at the left end of this thing. And then let's move it forward a couple of frames. That's pretty good. So 0.0167 seconds, and it ends up at 4 centimeters. So the starting position was 0. The final position was, what did I say, 4 centimeters. The starting time was 0, and the final time is 0.0167 seconds. 0.0167 seconds. And then I set up this very last column in the table to automatically calculate the velocity for you. And it gets 239 point stuff centimeters per second. That's 2.4 meters per second. Okay, so I got that by saying it's at one position, it's at another position later on. So that's the distance it traveled. It traveled 4 centimeters. And then it was at one time and then a later time. So that's the amount of time that has taken place in between those two frames. And then it calculates the change in the position divided by the amount of time, and that gives you the velocity. So I've just calculated the velocity for one drop height. Okay, so we're trying to find a relationship between the velocity that it gets to and the height, which means I need a bunch of different heights. So this graph right now is showing one data point for the height and the velocity. I need more heights. I need all 11 of them. So I'm now going to switch this to a different height. It was on height K, so let's go height J. So I go in order. Load. Okay, and you can see it's moved down a little bit. So I'm going to move this thing for the center of the mass to right there. And I'm going to make sure that it ends up at the same place. Let's see. A little further. There we go. So there's the final height. So the change in height from beginning to end is 0 up to 24 and a half centimeters. So I go down here and I put 24 and a half centimeters for the height. And then I'm going to measure two different positions when it's down here on the flat part. So I go set my clock right now. So that's 0. The position is 0. So initial position is 0. Initial time is 0. And then the final position a couple frames later is, let's see, trying to find one where it lines up with one of the lines. There we go. At 6 centimeters, it's at 0.0292 seconds. So 6 centimeters and 0.0292 seconds. And then it calculates the velocity for me, which is a little bit slower. And that kind of makes sense because it's falling from a slightly smaller height, so it's going to end up at a slower speed when it gets there. And then you can see that the graph is already set up to put those 2 data points in there. So you're going to fill in the rest of them and figure out what is the relationship between the height and the velocity. And the core question is it a line or is it some other relationship between the velocity and the height?